Welcome back, architects. I am absolutely thrilled to have you here for this explainer because, well, today marks a massive milestone in our system design journey together. We have officially reached day 14. Up until now, we've talked a lot about servers, routing, and processing data. But today is the crucial pivot point. It's the day we finally figure out where our system's data actually lives. We are diving deep into the DNA of digital persistence, object and file storage. If you've ever found yourself wondering how the world's biggest apps handle literally billions of photos and videos without just crashing, well, you are in exactly the right place.
Okay, let's dive into this. Here is our structural blueprint for today. We're going to kick things off with the core storage types. Then we'll move into S3 concepts, discuss managing image and video storage, break down the actual upload architecture, and finally, we'll wrap up by building our scalable mini project.
Section 1. The core storage types. Understanding file, block, and object storage. This is really our journey's starting point today, where we gather the raw theoretical building materials we need to construct a solid backend.
First up, we have file storage. Think of this as the foundational, traditional method of organizing data. It's your standard hierarchical directory structure, folders within folders, and it heavily relies on POSIX compliance. Now, it's highly intuitive, right? And it's great for local networks or simple apps. But there is a major bottleneck here. As your system scales up to, say, warehouse proportions, having to traverse deep folder paths just to retrieve a single piece of data introduces significant latency. It's just not built for planetary scale applications. So let's move to and see how this builds our next capability with block storage. To get high performance and super low latency, we actually strip away that hierarchy completely. Instead, data is chopped into raw, unformatted chunks or blocks, and each one gets a unique address. Because these blocks are directly accessible by the operating system without any of that folder overhead, it is incredibly fast. Honestly, this makes block storage the absolutely non-negotiable choice for IOPS-heavy, mission-critical databases where speed is literally everything.
And finally, to conclude our core storage taxonomy, we have object storage. This is a modern, totally flat structure approach built specifically to handle massive amounts of unstructured data. Instead of traversing a complex directory tree, files are just bundled with customizable metadata and a unique global identifier, and then stored in one giant flat bucket. With zero hierarchical constraints slowing things down, it scales virtually infinitely. So whether you're storing millions of user avatars, sensor data, or just petabytes of backup files, object storage is exactly what you need.
Now, what's really interesting about comparing these three is how clearly it highlights the architectural trade-offs. File storage gives you a general-purpose hierarchy for basic sharing. Block storage, it sacrifices that structure entirely for pure, unadulterated database performance. And object storage sacrifices localized speed for infinite, unstructured scale. Choosing the correct material here is absolutely vital. Like, if you try to run a high-speed database on object storage, it's going to lag. But if you try to store petabytes of user videos on block storage, you will literally bankrupt your project. You've got to match the tool to the task.
Section 2, S3 and object storage. The industry standard. Let's transition from the theoretical concept of object storage to its most famous, practical, real-world application.
Out in the industry, object storage is virtually synonymous with Amazon S3. The architecture here relies on three bite-sized core pieces. First, buckets. These act as your top-level containers. Inside those are objects, which are the files themselves, permanently glued to their metadata. And finally, keys. These are the exact unique identifiers used to locate the objects. It's almost like a giant puzzle. Combine a bucket and a key, and you can retrieve any file via a simple HTTP request from anywhere in the world. It is brilliantly simple, yet infinitely scalable.
Section 3. Managing image and video. The payload. Now we need to talk about the specific heavy payloads our storage architecture actually has to carry securely.
When we talk about image and video, we are talking about truly massive payloads. Look, text data is light. Your servers can pass millions of rows without breaking a sweat. But a 4K video file? That is a completely different beast. So here's why this directly matters to your system design. If you choose the wrong storage type or the wrong routing for heavy media, your entire system will just buckle under the weight. You absolutely have to optimize, compress, and store these payloads in a dedicated layer designed specifically to handle those massive bandwidth requirements.
Section 4. Designing the upload architecture. The pipeline. Let's pivot from the what to the how and look at the pipeline required to actually move these heavy media payloads into our storage banks.
Here is exactly how a file moves from a user's device into permanent storage in a professional system. Step 1. Client request. The client requests an upload but sends only lightweight metadata to the server. Step 2. Server routing. The server validates that user's request, checks their permissions, and then generates a secure temporary pre-signed URL from S3, handing it right back to the client. And Step 3. Storage execution. The client uses that secure URL to upload the massive media payload directly to S3. Notice the brilliance here. The heavy lifting completely bypasses your delicate application server. The server is really just acting as a traffic cop.
But, it makes you wonder, how do we make all of this scalable? We have the concepts, we have the pipeline, but what happens when 10,000 users try to upload a 4K video at the exact same second? This right here is the ultimate architectural test.
Section 5. The Scalable Mini Project. Synthesizing Theory into Practice. Welcome to your capstone, architects, where we finally synthesize all these raw materials and pipelines into a working, scalable application.
And this brilliantly illustrates exactly how far you've come. Look at a beginner's non-scalable setup. Users are uploading files directly to the application server's local hard drive. As traffic spikes, the server fills up, runs out of memory, and the whole shebang just dies entirely. But in the robust, scalable image and file storage system you just learned to build, we use a fleet of stateless app servers that simply hand out secure S3 upload URLs. Users upload directly to object storage, and a content delivery network serves those files globally. The load is distributed, the storage is infinite, and the system is basically unshakable.
By doing this, you've successfully separated your data from your computing power, effectively future-proofing your architecture. You've mastered file, block, and object storage, and designed a pipeline that can handle literally the heaviest payloads on the internet. But it leaves us with one final, provocative question. With this incredibly scalable foundation now built and humming flawlessly, what new boundaries will we push in day 14? Actually, scratch that, day 15. How do we search all this massive amount of data? How do we cache it so it's even faster? Well, you'll have to join me next time to find out. Keep building, architects, and I will see you in the next explainer.